So you're trying to land a job in AI, right? The market is absolutely on fire. But let's be honest, the interviews can be brutal. They're not just about what you know, they're really designed to test how you think. And that's exactly what we're going to do here. We are going to crack the code on the AI interview by breaking it down into 4 essential pillars.
Okay, so here's our game plan. We'll kick things off with a quick look at the interview landscape. Then we'll dive into those 4 key pillars: mastering the foundations, getting deep into algorithms and theory, tackling real-world problem solving, and finally, what I call the critical human element. Stick around because at the very end, we're going to reveal the one question that interviewers are really asking underneath it all.
All right, let's get right to it. What's the big problem we're all trying to solve here? Well, it's pretty simple. You want to land one of those amazing AI jobs, but getting there means you have to get through an interview process that is so much more than just a coding test.
But here's the flip side, and this is huge. A recent survey found that a staggering 75%, 3/4 of employers are struggling to find people with the right AI skills. You see that? That gap? That's your advantage. If you can master these pillars we're about to cover, you won't just be competing, you'll be the one they're looking for.
All right, let's jump into pillar 1, mastering the foundational concepts. I want you to think of this stuff as the table stakes in a poker game. You can't even sit down to play if you don't have these. An interviewer just assumes you know this stuff cold, and honestly, it's often the very first thing they'll ask you about. First up, the classic question. What's the difference between AI, machine learning, and deep learning? You've got to know this. Think of it like a set of Russian nesting dolls. AI is the biggest doll, the whole broad idea of making smart machines. Inside that, you have machine learning, which is a specific way to do AI where machines learn from data. And then, inside that, you have deep learning, which is a superpowered type of machine learning that uses these big, complicated neural networks. If you can explain that clearly, it shows them right away you get the big picture.
Okay, next up, the 2 main types of machine learning: supervised and unsupervised. The whole difference, and this is the key, comes down to the data. Supervised learning, that's like studying for a test with the answer key right in front of you. All the data is labeled. Unsupervised learning is the total opposite. It's like someone dumps a giant box of unsorted Legos on the floor and says, find the patterns. You have no instructions, just the raw data.
All right, with those basics locked down, we're ready for pillar 2, algorithms and theory. This is where things get a little more technical. The interviewer is going to start digging to see if you really get what's happening under the hood. You know, it's one thing to import a library in Python, but it's another thing entirely to understand why it works. That why is what they're looking for. A concept that is absolutely central to everything is the bias-variance trade-off. Okay, think of it this way. High bias is like trying to draw a map of a city using only a straight ruler. It's too simple, you miss all the curves and details. That's underfitting. High variance is the opposite. It's like trying to trace the map so perfectly that you even draw on the cracks in the pavement. It's too complex. You're just memorizing the noise. That's overfitting. And your job, the whole game, is to find that sweet spot right in the middle. And that brings us to, I swear, one of the most common technical questions you will ever get. What is overfitting and how do you stop it? So overfitting is basically when your model becomes a little too smart for its own good. It doesn't learn the general rules, it just memorizes the training data, noise and all. So yeah, it gets an A+ on the homework it's already seen, but then it completely bombs the final exam when it sees new questions. So how do you fight back against overfitting? Well, you've got a toolkit with 3 main weapons. First, you can just keep the model simpler. Don't use a giant neural network when a simple decision tree will do. Second, you use something called cross-validation, which is a clever way to test your model on data it hasn't seen yet. And third, you can use regularization, which is a fancy term for a technique that basically punishes the model for getting too complex.
Okay, but how do you actually see how well your model is doing? A really powerful way is with an ROC curve. All it does is it plots the good stuff, the true positives, against the bad stuff, the false positives. It gives you a visual of that trade-off. What you want is a curve that shoots up to the top left corner. That's a rock star model. If your curve is just a straight diagonal line, well, your model is basically just flipping a coin.
Another big one from the theory world is Bayes' theorem. Don't let the name scare you. At its core, it's just a mathematical way of getting smarter. It tells you how to update what you believe when you get new information. In the ML world, this is the engine behind some classic algorithms, like the naive Bayes classifier. It's surprisingly effective for things like, you guessed it, spam filtering.
Okay, deep breath. We've done the fundamentals, we've done the theory. Now it's time for pillar 3, real-world problem solving. This is where the rubber really meets the road in an interview. They stop asking you textbook questions and they give you a messy, incomplete, real-world business problem and just look at you and say, so, what would you do? Here's a perfect example you might get. Okay, they'll say, your fraud detection model is flagging 12% of all transactions. That's great. But our fraud team can only manually look at 2% a day. What do you do? See? This isn't a math problem anymore. It's an operations problem. They want to see if you can think beyond the code and understand the real-world limits. A rock-solid answer here shows you think in layers. You don't just give one solution. You say, okay, first, let's stop sending simple flags. Let's send a risk score from 1 to 100 so the team can focus on the absolute worst offenders. Then you'd say, for anything that scores, say, a 99 or 100, let's just automate it and block the transaction. And then for the masterstroke, you say, and we can actually retrain the model to be laser-focused on being super, super accurate for just that top 2% that the team can actually review. That's a complete answer. Okay, here's another curveball they might throw at you. You need to build a vision model to spot defects on a factory assembly line. The client is adamant you cannot miss more than 1% of defects. Oh, and by the way, you have 0 labeled data to start with. Go. This is a tough one. The stakes are super high, and they're testing how you handle the classic cold start problem.
The way to tackle this is not with one magic solution, but with a phased approach. You'd say, okay, phase 1. We start with transfer learning. We take a pre-trained model that's good at finding something similar, and we start there. Then, phase 2. We launch it, but we tune it for what's called high recall. That means we're going to get a lot of false alarms, but that's okay, because we would rather have 100 false alarms than miss one single real defect. And here's the most important part. Phase 3. Every single item our system flags, whether it's real or not, gets reviewed by a human. And that becomes the seed for the perfect labeled dataset we'll use to make the model better and better over time.
So we've covered the tech, we've covered the practical application, but there's one more piece. And honestly, this is often what separates the good candidates from the great ones. Pillar 4, the critical human element. This is all about ethics, communication, and teamwork. It's the stuff that proves you're more than just a coder. I can almost guarantee you're going to get a question about ethics or responsible AI. And listen, this is not a trick question or a checkbox they need to tick. Major companies are deeply concerned about this, and they need to know that you are actively thinking about the real-world impact of the systems you build. A great answer here isn't about having some perfect philosophical statement. It's about showing you have a process. You should talk about being proactive, asking questions like, have we checked this model for bias against certain groups? Or can we explain why the model made this decision? Thinking about things like transparency, data privacy, and security. Ultimately, it's about showing that you always keep the human at the center of the design. And then there's the translator test. They'll ask you something like, tell me about a time you had to explain a really complex AI concept to someone non-technical, like a project manager or a marketing lead. And what they're testing for is simple. Can you bridge that gap between the tech and the business? Because look, the most brilliant model in the world is completely useless if the people who need to use it don't understand or trust it. Your ability to make the complex simple is a superpower.
Okay, so we've gone through all 4 pillars: the foundations, the theory, the problem solving, and the human element. Let's pull it all together. When an interviewer is asking you all these different questions, what are they really trying to figure out?
It really boils down to one simple idea. They don't just care about what you know, they care about how you think. An interview isn't a pop quiz where you just spit back memorized answers. It's a live demonstration of your mind at work. They want to see you wrestle with a problem, they want to hear you talk through the trade-offs, and they want to see that you can connect the tiny technical details to the big picture goal. So what are they really looking for? They're not just looking for a model builder, they're looking for a problem solver. Someone who gets the foundations, who respects the theory, but who also knows how to apply it creatively within the messy constraints of the real world, and who does it all with a deep sense of responsibility. You show them that person, that's the candidate who gets the job.